Okay, let's go ahead and talk about lesson 32. This is all about probability. You have two objectives right here. One is to calculate probability, and the other is to calculate odds. Probability is a pretty big concept, very important. Let's go ahead and get started. Here's your fun fact of the day. Nepal is the only country out of the entire world that doesn't have a rectangular flag. You can see right here what its flag looks like. Alright, so fun fact of the day. Let's go ahead and get started with the lesson. Okay, so sample space is part of probability. It's a very important part, okay? Sample space is all the possible outcomes of an event. Okay, so let's talk about what that means here. I want to know what is the sample space of rolling two dice at the same time. So I want to know what's every possible outcome that I could get if I rolled two dice at the same time. Now, we need to know what the event is, okay? The event is rolling two dice at the same time. So that's what's happening. So I'm going to roll dice 1, and I'm going to roll dice 2. Whoops, I don't need to put roll dice 2. I know I'm rolling it. Okay, but I'm going to roll dice 1, I'm going to roll dice 2. Okay, we know that. So what can happen when I roll dice 1? Well, I know, if I know anything about dice, that I can get a 1, a 2, a 3, a 4, a 5, or a 6. And if I roll dice 2, those are the exact same options, assuming it's a normal 6-sided dice. Okay, a 1, a 2, a 3, a 4, a 5, or a 6. Sample space means what are all the possible outcomes? Well, I know that one thing that can happen is dice 1 could be a 1. Okay, and I'm actually going to erase that and move that up a little bit here. I could roll dice 1 and get a 1. And dice 2 could also be a 1. So I could get a 1 and then a 1. If dice 1 is a 1, I could also roll dice 2 and get a 2. So I could have a 1 and then a 2. Or I could get dice 1 as a 1 and dice 2 as a 3. Okay, and this pattern could keep continuing. 1 and a 4, a 1 and a 5, and a 1 and a 6. Okay, now notice, I did not add these numbers together and just say a 1 and then a 1, that's 2, and a 1 and a 2 is 3. I didn't do that because it didn't ask me for the total of rolling two dice. If it would have said what's the sample space of the total of rolling two dice, then I would have had to add those up, because total means to add. Okay, but we're going to just leave it like this. I can get a 1 and then a 1, 1 and then a 2, 1 and then a 3, and so on. Okay, well, dice 1 doesn't have to be a 1. I have all these other options right here. Okay, so I could roll dice 1 and get a 2 first. And if I do that, I could roll dice 2 and get a 1. Or I could get a 2 and then a 2. And I could keep that pattern going again. And then a 5 and then 2 and then a 6. And we'll notice here we've got some things that look like crossovers. This says 1 and a 2, and this says 2 and a 1. And we have to consider those different outcomes, okay? Because, again, it doesn't ask for the total. These things aren't 3. This is a 1 and then a 2, or a 2 and then a 1. Okay, so those are different things in this case because there's no word total there. So I'm going to continue this pattern here, and you're going to notice there's a lot of different results that can happen. I could roll dice 1 and get a 3, and pair it with a 1 from dice 2, a 3 and then a 2, 3 and then a 3, 3 and then a 4, 3 and then a 5, 3 and then a 6. I could do the same thing with rolling a 4 first. And I could do the same thing with rolling a 5 first. And I could do the same thing with rolling a 6 first. So if you take a look at this, this is my sample space. Okay, that's all the possible things that could happen if I roll those two dice at the same time. Okay, and if I were to count these up, there's 6 in this row, 6, 6, 6, 6, and 6. Well, 6 times 6 is 36 different outcomes. If they ask me how many different things could happen if I roll two dice at the same time, there's 36 different outcomes right there. Okay, now if they ask us things like about how many times do we see doubles? Well, doubles means the same number occurring twice. So that'd be like 1 and a 1, a 2 and then a 2, 3, 3, 4, 4, 5, 5, 6, 6. So there's 6 sets of doubles here out of the 36 total outcomes. Okay? So things like that are worth to pay attention to. But sample space means tell me every possibility, and yes, you have to write them all out. The sample space is writing out every outcome, not telling how many there are. Okay, there are 36 outcomes here, but this whole block of stuff is my answer for what is the sample space. I wrote out every outcome. Okay? So, let's say I ask you for the sample space of flipping a coin. Okay, what's the sample space of flipping a coin? Well, if I flipped a coin, I can get heads or I can get tails. That's it. This would be the entire sample space, heads and then tails. That's my only option if I flip a coin once. Okay, that is all. So, but that's what sample space means. Tell me all the possible outcomes. Okay, probability versus odds. You have to know the difference in between these. Probability is a ratio, okay? It's written like a fraction typically or a percentage. Okay, it could be a decimal too, but it's a ratio of what we call the number of favorable outcomes compared to the number of total outcomes. Okay, we'll talk about what that means. Odds is a ratio of the number of favorable outcomes to the number of unfavorable outcomes. Okay, and again, ratios can be written this way. Probability is usually written as a fraction or a percentage. Odds are often written like this, with a colon in between. That's why I wrote it that way. So let's talk about what this means. What are the probability and the odds of a flipped coin landing on heads? Okay, well, the probability of a flipped coin landing on heads, the number of favorable outcomes. Well, favorable outcomes are what are they asking you about? They're asking you about the probability of it landing on heads. So the probability is the number of times it could land on heads over the total number of outcomes. Okay? Then odds would be the number of favorable outcomes, so that's heads, compared to unfavorable outcomes. Well, if I know anything about flipping a coin, I can get heads or I can get tails. So in this case, tails would be the unfavorable outcome, because the favorable is landing on heads. That's got to come first. So again, here we got favorable to unfavorable. And this one is favorable over the total. So if I flip a coin and it says I'm only flipping a coin, it's a flipped coin and I'm only flipping it one time. So that means I can either get heads or tails. So probability-wise, one of those is the favorable outcome, heads, and there are two total outcomes, so the probability is a half. And then for odds, the number of favorable outcomes is heads, and the number of unfavorable outcomes, well, I only see tails one time in my sample space, so here's the odds. So the probability is 1/2, and the odds are 1 to 1. Okay, for every one time I could flip heads, there's one set of unfavorable outcomes, tails, to match up with it. So again, probability, favorable over the total, odds are favorable compared to unfavorable. So let's go ahead and do some more examples here. The spinner at the right is spun once. What is the probability the spinner will stop? And then we have three different sections here. So what's the probability the spinner will stop in sector A? So I want to know the probability of getting an A. Well, I know probability is the number of favorable outcomes, which in this case is landing in sector A. So if I look over here, there's only one spot on this spinner that is sector A. So I'm going to put a 1 for that one spot. I'm going to put it over the number of total outcomes. Well, I can get an A, a B, a C, or a D. So there's 4 possibilities there. So there's the probability of getting an A, 1/4. Okay, so for part B, I want to know the probability of an A or a B. Okay, so the number of favorable outcomes is anything that's an A or a B. Well, there's one spot that's an A and one spot that's a B, so that's 2 spots that are A or B, and there's still 4 total spots on the spinner. Now we have to reduce that probability. That's equal to 1/2. Okay, you always reduce fractions on probability. And again, that should make sense because 1/2 of the spinner is filled with A and B. Okay, you could also write it as a percentage. We could say that's or 50%. We could say that this one is 25%. Okay, different ways to write probability. I like leaving it as fractions. So, let's go ahead and see. The probability it's going to stop in sector A, B, C, or D. Well, A, B, C, or D, that's 4 choices out of, and there's still 4 spots on the spinner. So 4 out of 4, that's 1. So the probability is just 1, which would be the same as 100%. Alright, So again, probability, we can write it as reduced fractions. You could write it as percentages. You don't need to write it as a percentage. They don't tell you to. Okay, so keep that in mind. Let's go ahead and keep on moving on. Okay, Nathan flips a coin 3 times, and we need to predict what is more likely, that he will get heads at least once or that he will not get heads at least once, and we want to find those two probabilities. Okay, well, first thing is that we need to know about probability is how many total outcomes there are. Okay, so Nathan's flipping a coin 3 times, so he's going to flip it once, and then flip it again, and then flip it again. Okay? Well, one way, first of all, we want to figure out the sample space. And the reason why I didn't do that on the spinner is because the sample space was easy to see. There was a visual there. We knew that there were 4 different things that could happen on that spinner. So I didn't really have to write out the sample space on that one. Flipping a coin 3 times is a little trickier. So here's a method you can use to write out the sample space. You start with your first event. So I'm flipping the coin once. And think about what your options are. I can either get heads or I can get tails. Okay? Well, if I get heads with the first flip, I have 2 different options for the second flip. I can get heads again, or I can get tails again. And the same thing would happen if I were to flip tails. I can get heads after that on the second flip, or I can get tails. Okay? Well, after the second flip here, I have a third flip to do, and I know that if I got heads and then heads, that I have 2 options again. I can either get heads on the third flip or tails. And same thing here. I can get heads or tails, and I can get again heads or tails, and one more time I could get heads or tails. Okay, so this tree diagram is showing me all my options. So here's how this works. Is the first time I can flip heads, the second time I have another option to get heads, and the third time I could get heads again. So one thing I could do is get heads, and then heads, and then heads. Okay? Well, if I start at this first flip again, and I get heads the first time, I could still get heads the second time again, but then I could get tails the third time. So another option is heads and tails. Okay? And then same thing. I can get heads the first time and then get tails and then heads. So I can get a heads and then tails and then heads. Or I could get a heads and then tails and then tails. That comes from right here. Heads to tails to tails. That's everything that could possibly happen if I get heads first. Notice here, there's 4 possibilities if I get heads first. Here's if I get heads first, and look at all the stuff it's connected to. 1, 2, 3, 4 different outcomes at the end. So there you go. Well, I could also get tails first. I could get tails and then heads and then heads. I could get tails and then heads and then tails. I could get tails and then heads. Or I could get tails and then tails again. Okay, so there are 8 possibilities for things that can happen if I flip a coin 3 times. These are all of them right here. This would be my sample space. Okay, so part A says predict which one's more likely. That's something we really should have done before this. Okay, that he will get heads at least once or that he will not get heads at least once. Okay, well, let's go ahead and skip to B and C. Because predict is just something you can do. You can think what you think is more likely. Maybe you thought they were both equally as likely. I don't know. But so we're going to go ahead and find the probability of getting heads at least once. Okay, so I'm going to find the probability of at least 1 heads. At least means greater than or equal to 1 heads. That's how I'm going to write that. Okay, at least means 1 or more heads. So I need to look at all this sample space and figure out the favorable outcomes, which are anything where I see heads at least once. Well, this has heads at least once, so that's 1, 2, 3, 4, 5, 6, 7, and then this one does not. So 7, okay, is the number of ways that I can get heads at least 1 time, which means 1 or more. And that's out of how many possibilities total? Well, there's 8 possibilities. And this is a reduced fraction. Okay? So if I flip a coin 3 times, it is very likely that I get heads at least one of those times. At least 1 out of 3, I should be able to get heads, which should make sense if there's a 50-50 chance that I get heads every single flip. Alright, and the probability of not getting heads at least once. So that's all the times in the sample space that I don't see heads at least once. So I'm looking here going, this is the only time where there's not at least one head. Okay, so probability of not getting heads at least once pretty much means 0 heads. Okay, we want to get no heads, we want to get all tails. So that's 1 out of 8. And if I look at these two numbers, the probability of something happening and then of not that thing happening, those are called complements, and they should add up to 1. Okay, so 7/8 plus 1/8 equals 1. So that should make sense. So another way I could have done this, part C, is to figure out this one, and then just figure out what's left over. There was 1 out of 8. Alright, let's go on to the last example. Actually, I guess it's not an example, sorry, some more notes here. Experimental probability versus theoretical probability. Okay, experimental probability is what actually happened. Okay? And theoretical probability is what should happen if I actually were to do the event. Okay, so for example, here we go. Mr. Ayers flipped a coin 4 times, and the coin landed tails 3 times. If I want to know what the probability of the coin landing tails 3 times is an experimental probability, that just means tell me what actually happened. Well, it landed tails, so probability of landing tails, it happened 3 times out of the 4. Okay, when I actually flipped the coin. Well, if I know much about probability, is that what should happen? Theoretical means what should happen. If I flip a coin 4 times, how many times should the coin land tails up? Here it landed tails up 3 times, but I know the probability of it landing tails is only 1/2. So half of this is 2. Okay, so theoretically, what should happen if I flip a coin 4 times is I should get 2 tails and 2 heads, because there's a 50-50 chance. But when I actually did the experiment and actually flipped the coin 4 times, I got 3 tails, which means I only got 1 head out of the number of times I flipped it. Okay, so again, experimental is tell us what actually happened, which pretty much just ends up writing the information you're given. Okay, and what should happen is thinking about the theoretical, what should happen if you flip the coin that many times, and then figuring out based on that. Okay, and that's all for probability. Let's go ahead and get started on the homework, and if you have any questions, make sure you ask. Happy homeworking.